Are you guys ready for some hardcore guitar building CNC action? I'll bet you are. Well, let's get it on. Hey guys, if you value and appreciate the information that I share here on my Highline Guitars YouTube channel, consider supporting my channel by visiting eguitarplans.com and purchasing a plan for either building a guitar or one of the tools that you can use to build a guitar. And if you would like to help support the channel but want something more tangible, you can purchase a t-shirt from my merch shelf down below. Either way, there's links in the description. In this episode, I'm going to be making the body for the 4-string bass guitar. And what I'll be doing is carving it from this big old slab of alder. This is roughly 16.5 inches wide and then a little over 22 inches deep. And the thickness is about 1 3/4 inches. Now what I've already done is I have marked a center line down this edge and then down this edge, which indicates the center of its length. And then since this was made from 2 pieces that were glued together, I'm using the glue line, the seam, as the center for the width. And I'll be using these lines to position the blank on the CNC machine. Because as I mentioned in previous videos, I have a line which runs from the front of the wasteboard all the way to the back, and it's parallel with the y-axis rails. Then I have another line that runs across the width that is parallel with the x-axis. So I can line these two up, get everything positioned correctly, and then I'll clamp it down. And then once I'm finished carving one side, I can then flip the blank over, register it once again with those lines, and carve the other side. And that way everything is going to line up. All right, what I'm going to do now is I'm going to home the CNC machine. And what that means is I'm going to move the gantry and the spindle all the way to the lower left corner. And this is an automatic operation. So as the machine, as the structure moves, it's going to trip several limit switches. And once those are tripped, the spindle, the center of the collet on the spindle will be directly over this lower left corner, and that becomes a known position. So from there, I can precisely jog the spindle to the XY start position. So now, the spindle is directly over my XY 0 start position. So what I have to do now is put in a bit and then use my probe to determine precisely the Z-axis start position. The first carving operation is going to be to drill the holes for mounting the neck. And that will also include the recess for the neck mounting ferrules. And to do that, I'm going to be using a 1/8 inch diameter 2-flute spiral upcut bit. So I'll chuck that into the collet. And then I'm going to use the probe to determine exactly the Z-axis 0 position. The way this works is when the bit touches this piece of brass, a connection is made and a signal is sent to the machine, which then will back the spindle off by a specific amount. So the machine will know exactly how far off the surface the tip of the bit is. Okay, so now the spindle, the tip of the bit actually, is in the XYZ start position. So from here I can start my carving operation. Now, as you can see, once the carving operation was finished, the spindle returned to the XYZ start position. What I'm going to do now is I'm going to raise the spindle and I'm going to swap out that 1/8 inch bit for a 1/4 inch diameter 2-flute spiral upcut bit. And I will use that for the next carving operation, which is going to be to carve the belly relief contour. Since I changed the bits, I'm going to have to probe it again to make sure that I get that tip precisely located in the Z-axis start position. The spindle's back in the XYZ start position. So what I'm going to do is I'm going to raise the spindle and I'm going to swap out this 1/4 inch end mill with a 1/4 inch ball bit. And then the next carving operation is going to be a finishing pass on this belly relief area to smooth out the surface, because as you can see, the rough carving operation leaves the surface terraced or stair-stepped, and I want it to be really smooth. That'll save a lot of time with respect to sanding later on. As you can see, the spindle returned to the XYZ home position. So what I'm going to do now is I'm going to raise the spindle up 1 inch, and then I'm going to jog it back exactly 24 inches. Then I can unclamp the blank and flip it over so that I can start carving the top side of the body. So the blank is now flipped, the spindle is in the XYZ start position, and what I need to do now is raise the spindle and swap out this 1/4 inch bit for a 1/16 inch bit, which is what I'm going to use for the first carving operation on the top side of the guitar body. And that operation is to drill the pilot holes that'll be used for mounting the pickguard later on. So now what I'm going to do is I'm going to raise the spindle and swap out that little 1/16 inch bit for a 1/4 inch diameter 2-flute spiral down cut bit. And I'm going to use that to start cutting the pockets for the neck, the pickups, and the control cavity. And the reason I'm using the down cut is because I'll use that to do just a shallow pass around the perimeter of those pockets. The down cut bit will do a much cleaner cut without the associated fuzzy edges or possible tear out, which can be common with alder. And then once I've done that initial pass, I'll swap that bit out for an upcut bit, which I'll use to hog out the rest of the wood from those pockets. Okay, for the next carving operation, I'm going to be cutting the shape of the guitar, the perimeter shape, as well as the forearm contour. Now to do this, because of the thickness of the body, I need to swap out this 1/4 inch two-flute spiral upcut bit with it's basically the same bit, it's just longer, so it can reach all the way down through that 1 3/4 inch thickness. So I'll swap it out. I'll set the Z-axis height with my probe and then start making that carve. As you can see, the forearm contour has that stair step, and that's typically what you can expect when you do a rough carve. So what I'm going to do is I'm going to raise up the spindle again, swap out the end mill for a 1/4 inch diameter ball nose bit, and I'll use that to clean up that surface and really smooth it out. All the CNC work for making the guitar body is now complete, and it took about an hour and a half to do the work. It probably actually took me a little bit longer because I'm shooting video in the process, and that means I've got to set up the camera and the lighting and do the hair and makeup and all that kind of stuff. But you can expect to do a precision-based style guitar body, and this would also be true for like a Strat style body or a Telecaster, would take about an hour and a half. If I was doing a carve top, like a Les Paul type shape, that might take a little bit longer, but we're looking at under 2 hours, so that's pretty much what you can expect. In the next episodes, what I'm going to be doing is some prep sanding as I get the body ready for primer and paint, so be sure to check that out. And as always, don't forget to like, comment, subscribe. And until the next episode, take care, stay safe, and I hope you'll be back for the next episode.